This is a simple code, or a program rather, that is an example of a numerical calculation. A numerical calculation is a calculation that is not easily solved by hand, and that is where the computer comes into play. The purpose of this particular code is to computationally model the E field of a dipole, which in this case is a proton and electron of equal and opposite charges. I have broken the code up into three basic parts, which are your constants, drawing, and loop. The constants at the top of the screen are where you're going to get the information, pretty much, to solve the calculations within the loop section. And to give a little bit of insight upon this, the scale factor is how big your arrows of your product are going to be, or how wide. It helps to scale it so you can get a better view. UFPES stands for 1 over 4 pi epsilon. And the rest are pretty self-explanatory. In the drawing section is where we have our visual aid, and this will come into play as I will show you whenever the program is run. OBSLOC, right there within the drawing section, stands for the observation location. That's pretty much where we're seeing what's going on. In the loop section, I call it double loop because it pretty much is. You have a for loop with a while loop within it, and both of them have different stopping points. And within it are all of your calculations. A couple to kind of pay attention to is the EP, EE, and E total. EP is the electric field of the proton. EE is the electric field of the electron. And E total, well, that's EE plus EP. In this case, we're focusing on the electric field of the proton, which is going to be illustrated or shown in our visual aid by R arrow and E total. E total will be very small arrow shown in blue, as you will see, and R arrow is the vector of the E field for the proton, which is what we are trying to solve for with this program. Here is the visual aid of this program. As stated before, these big green arrows are the vectors, or the E field, of the proton. And these small blue arrows within is E total. And right here, I just thought I'd show is, in the program, we wanted to find, or we wanted it to print EP, which is the E field of the proton. This is the answer that we get for the E field of the proton. And there you go. That's an example of a numerical calculation, and this one in particular, trying to computationally model the E field of a dipole, which again in this case is for a proton and electron of equal and opposite charge.